in the last class, we have started with ordered pair, introduction to relations, and type of relation. We have seen ordered pair where A and B that both are related to a single set where they have some relation between them. That is, we prefer to say ordered pair. This is Cartesian product of two sets. We have seen like if it is having M, this is having n elements, then A cross B will be M cross n elements. Then we have started like what is the domain of a relation, what is the range of a relation, and what is the inverse of a relation. Domain means all the first letter of the ordered pair, range means all the second letter of ordered pair, and inverse we know if we change B with A, this is going to give you inverse. Okay. After that we have seen basic one like void relation where we are not going to get any relation, we are going to prefer to say it is void relation. After that universal relation where the number of ordered pair in the relation itself it is equal to the cross multiplication of two different sets. So this is the thing which we have to remember to identify if some relation it is universal or not. In the last one we have seen this is the identity relation where we find all the ordered pair in this form, in the form of A comma A. Okay, we have done this thing. Then we have started with quotient. This is the quotient, this is the quotient, and this is the last question. If you remember, I have solved this question to the like half of the question I have solved. The remaining half part you have to tell me, I guess. So yes, Amir, you, anyone? Like if you remember, we got the answer till what we have solved. Like we got the answer for A equal to B. How many certain cases we are having? 10. Okay. Let me solve once. So everyone just see here. So in the last class we have solved this question. Like I guess 60% solution I have done. Let's solve this question once again. Then we will proceed with the remaining stuff of this chapter. So here let A is equal to 1, 2, 3, 4. We are having 10 elements and B is equal to 0, 1, 2, 3, 4. Now we have to find the number of element in the relation where the relation itself says that A comma B we have to choose such kind of ordered pair from A cross A where A this particular equation, if we put that particular AB in this equation, this is going to be belong to B. And what is the possible values of B? 0, 1, 2, 3, 4. Okay. So let's start very fast. Like we have solved this question. So again I am going to write this equation like 2A minus B whole square plus 3A minus B, and we can take 0 as it is reflecting B also. Okay. Let's take the common part, that is A minus B. Here we can say 2 into A minus B plus 3 is equal to 0. Now if you remember we are having two different situations. Like the first one A minus B equal to 0 and the second one it is 2 into A minus B plus 3 equal to 0. For here we can say it is A equal to B, and for here we can say A minus B equal to what? Minus 3 by 2. So now we know that in A cross A how many total order pair we will be having? A cross A. Tell me. In A cross A how many total number of order pair we are going to see? 100. Out of those 100 order pairs, we have to choose those one where we are going to get A and B both equal. Okay, so we can count in this manner 1 comma 1, 2 comma 2, 3 comma 3, and it will be continue till 10 comma 10. So can you tell me how many order pair we are going to get from here? 10. But here we can see like 10 is not available. It means some other condition we have to see. Like we have started with 0 only. We have to check for 1, 2, 3, 4 also. So let's start with the second part, like all the remaining cases. This is going to become A minus B, 2 A minus B plus 3 is equal to 1. Now we have taken 1. Now see, A and B, what are the possible values of A and B? These one, like either A could be 1 to 10 or B could be 1 to 10. So and here also this is going to, it means A minus B will be what? Integer. Similarly this is going to be integer. Now tell me two integers If we multiply both of the integer, then we are going to get 1. So tell me when it is possible. When we have to multiply two integers so that we can get 1. Can you tell me the case when it is going to be possible? Only when we multiply 1 with 1. Now what happen here, if we take a minus b 1, here also we are having a minus b, it means 2 into 1 plus 3. 2 into 1, 2. 2 plus 3, 5. So this is going to become 5 and this is 1. 1 into 5, here we are having 1. Is it possible? No. So we can't take this particular situation, okay? And for this situation, we don't have any other combination of, so that we are going to end with 1. So we are not moving further with this situation, okay? Let's start with the second one. 2a minus b plus 3. Let's have a look on 2. Now can you tell me, if we have to take two different or whatever integers, if we multiply both of them, we are going to end with 2. So how many possibilities are there? 1 into 2 and 2 into 1. If a minus b is 1, once again 2 into 1 plus 3, 1 into 5, 5 should be there, but it is written 2. So we are not going to start with this. Let's take 2. If a minus b is 2, 2 into 2, 4. 4 plus 3, 7. 7 2 cha, 14. But here it is written 2. It means in this case also we are not going to get any particular situation where we are going, like LHS is going to become RHS. So we are not moving further with this. Similarly, let's see a minus b, 2 a minus b plus 3 is equal to 3. Now once again there are only two possibilities, 1 into 3, 3 into 1. If we take 1, 2 into 1 plus 3, again 1 into 5, it should be written in this side 5. If you take 3, this is 3, 3 into 2, 6, 6 plus 3, 9, 9 3 ja, 27, but in this side we are having 3. So we can assume that like either we should go with 1, 2, 3, 4, we are not going to make any cases, okay. So we have to think differently. Like let me introduce the another kind of stuff, like a minus b is there, 2a minus b plus 3, it is equal to 2. Now earlier we have taken 1 into 2, 2 into 1. Can we take minus 1 into minus 2 or minus 2 into minus 1? Okay, why? Remember this thing, we are not actually looking for the negative value of a and b, because a and b will be from this particular set. Those are not going to be negative, but their difference could be negative, okay. Let's take a minus b equal to minus 1. If this is minus 1, 2 into minus 1 will be minus 2, 3 minus 2, 1, 1 into minus 1 will be 2, no, not possible, so then we can leave. If we take a minus b minus 2, just put it here, 2 into minus 2, minus 4 plus 3, minus 1, minus 1 into minus 2, what is the answer? 2. So this time we got this one, means a minus b is going to become 2, minus 2, and this is going to become minus 1. So we have to choose those particular order pair wherever we find the gap of 2. Like Yuvantika, you have written 4 out of them you have written. So can you tell me those order pair where we can find the gap of 2, starting from 1, comma 3, then 2, comma 4, then 3, comma 5, then 4, comma 6, then 5, comma 7, 6, comma 8, 7, comma 9, and 8, comma 10. So how many we are having here? 8. And how many here we are having? 10. So what is the final answer? 80. Okay. So write down the remaining stuff what you have written in the last solution. Then we will proceed further.